inscribed angles and polygons. That means when it says inscribed, that means that it is inside the circle. So that means that your angle is inside the circle as well as the polygon will be inside the circle. An inscribed angle is an angle whose vertex is on the circle and whose sides are the same chords of the circle. So if we look here, these are my points. Let's label this A, B, and C. This is an inscribed angle because your vertex of B is on the circle. Okay, so that is what makes it an inscribed angle. So we can put angle A, B, and C. So an intercepted arc is the arc that lies in the interior of the inscribed angle. So your arc is there. That is very important. You need to know where your intercepted arc is going to be. It is in between your angle. How would I name that arc? AC. That is my intercepted arc. All right, the measure of an inscribed angle. The measure of an inscribed angle is 1/2, underline that, 1/2 the measure of its intercepted arc. So here's my intercepted arc, my intercepted angle. All right, so as far as we know, what we learned earlier, look at that angle C. We learned that if this was 50, your arc was also 50. Right? That's what we've known up until today. From day 1 and day 2, we learned that your central angle is the same as that arc. But now that we have an inscribed angle, that angle D will be half of this arc. What's half of 50? So this angle will be 25. Any questions on this part? All right, let's practice. Find the measure of each arc and inscribed angle. So I'm going to highlight my inscribed angle. Michael, put that away. You're not going to understand this if you're distracted. All right, they want me to find what this measure of the arc is. In order to do that, I'm going to look and see what information I already have. They told me that angle R is a right angle. What degrees would that be? 90 degrees. Write that in. So if that is 90 degrees, my intercepted arc here is going to be 180 degrees. Because your intercepted arc is times 2 basically of the angle. I'm going to highlight and extend my angle here. I'm also going to highlight the arc. All right, my angle is 115. What is my arc going to be? 230. How do you get 230? 115 times 2. So this is 230 degrees. You get your notes back in?
No.
For letter C, intercepted arc. They told me that my arc was 100. What is this angle going to be? Huh? 50 degrees. I want you guys to do letter D. So for letter D, I can see that this is my inscribed angle. Before I even started, they told me that this central angle was 132, so I know that this arc is also 132. So I needed this central angle to get my arc. Once I have my arc, then I can find the measure of BAC because it is half of 132. You get 66 degrees. All right, so letter E is a little difficult. Let's look at just half the circle. I'm going to erase this eventually, so don't write this down. But look at this part. This half of the circle has to equal what? 180. They already told me that this part of the angle was 94. How can I find the top part? Which is? Alright, so my friend told us that this part here is 86. If that central angle is 86, what will this arc be? 86. Good. I needed that information before I went on. So here's my inscribed angle. Alright, I know that my arc is 86, so this angle here is going to be half of that. So what is my measure of angle BAC? What's half of 86, guys? 43. 43 degrees. Wait, my arc is 86. I divide by 2 to get my angle.
Is it because they're
Because they're what?
because they're vertical angles like that's on top down here? Just like if that angle's like that far away. That's why.
Okay, so take a look at. We only needed that so we could get my arc. Right? So this problem is like the same as this one. Just ignore this middle piece. If this arc is 86, this angle is going to be half of it. That's the same thing as here. It's just the same thing.
It's yeah.
Now, what's your question?
Because I'm just like it's like up there, but we're looking for the A plus and bottom, so shouldn't we find like the A to arc? But since they're vertical angles, it would be.
I don't care about the 80 arc because it asks me to find the measure of BAC. So the other arcs don't matter. And it doesn't matter whether it's at the top or bottom. It's the same thing as if we are. This is my intercepted arc. That's what's important because they already asked me to find BAC. That's why I highlighted that triangle or that angle. When you have arc to angle, so whenever you go, let's say here's my circle. Here's my angle. Right, let's say this is A, B, and C. I'm trying to find this angle here. This is my intercepted arc. So if I'm going from arc to angle, I divide by 2. Arc to angle, you divide by 2. So the opposite of that, if we go from angle to arc, what will we do? Then multiply that. That is what this whole lesson is based on. Finding your intersected arc or finding your inscribed angle. If your vertex is in the center, this is what we learned on day 1. Just a refresher for this problem. Your vertex is in the center, and let's say this is 40, then your arc is also 40. Draw another circle. Because if your vertex is on the circle, this creates your inscribed angle. So if this was 40, what would your arc be? Huh?
No, it would be 80.
It would be 80. Guys, do you understand the difference between the inscribed angle and the non-inscribed angles? That is a huge part of what we're doing. That's why I told you guys that this is by far probably the hardest lessons, because there's a lot of vocabulary that you have to know that you have to apply to these circles. Let's go over some rules. Do we notice here that there are 2 inscribed angles within this circle? Can you guys see that? I know Michael can. Can everyone else see that there are 2 inscribed angles in this first circle? Okay. You have to be able to recognize that. So here's one inscribed angle. And here's the other inscribed angle. You guys also see that both of these angles share the same arc. Is that clear, that both of those angles have the same exact arc? It's the purple one. So the rule here is that these 2 angles, because they share the same arc, those 2 inscribed angles are going to be congruent. So we can write angle C is going to equal angle D. Those 2 angles are going to be the exact same. So here's an example. Example 2. I can see here that I have 2 different inscribed angles. And you guys see that they have the same exact arc. GH, the arc GH is the same for both of these angles. You guys recognize that? Guys, yes or no? Are you confused or are you just being silent? Because if you don't understand, you need to say something. Do you guys see that this arc GH is the same for the yellow triangle and the yellow angle and the green angle? Yes. All right, so because you can see that, that means that these 2 angles here are going to be congruent. So if E is 75 degrees, what is the measure of angle F? 75 degrees. This is not the lesson to sleep through. There's a lot jam-packed into inscribed angles. All right, on letter B, I also have 2 inscribed angles. There's one, and there's the other one. They have the same exact arc. They share the same arc. Because they share the same arc, their inscribed angles are going to be congruent. They're pointing that each of those has an expression. The yellow angle is 2x plus 11, and the green is 4x minus 3. Because they are going to be congruent, how would I solve this? We'll make them equal to each other. You can use Desmos if you'd like. I'm going to actually solve So you can check your work with mine. You should get x equals 7. You guys get 7? All right, so there's one more component to this, and it is inscribed polygons. So we have a triangle and a quadrilateral. We all know what a triangle is. A quadrilateral has how many sides? 4. Good. So that could be a square, a rectangle, a kite, a rhombus, parallelogram, any of that. Anything with 4 sides is a quadrilateral, so that rule applies. Your right triangle rule says if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Do we see here that I have a right triangle inside this circle? What is my hypotenuse of that right triangle?
AC.
AC, good. It is also the diameter. Where would your right angle be? A, B, or C? B. I think it's pretty clear to see where your right angle is going to be. These are not going to be trick questions. For these questions, you're going to be able to tell which one is your right angle. Your right angle, B, is also going to be equal to what? What's your degrees for a right angle? 90 degrees. All right, so when there's a quadrilateral, when it is inscribed in a circle, it is if and only if it is a quadrilateral can be inscribed in a circle if and only if its opposite sides are supplementary. All right, supplementary, what does that mean? Right, 2 angles that add up to equal 180 degrees. Write that down. Even though you may know it, just write it down. All right, so we're looking at this picture here. Angle G and angle E are both going to be opposite. So those two combined will equal what? 180. Opposite angles, when you have a quadrilateral, opposite angles equal 180. So that means that D and F are opposite and they're also equal to 180. So angle E plus angle D is going to equal 180 degrees. And then angle D plus angle F is going to equal 180 degrees. The reason why this makes sense is because we know a quadrilateral has interior angles that add up to 360. So your opposite angles when it's within a circle will equal 180 degrees. What time do you guys get out of here? 11:20? 12. What time is it now?
10:50.
Huh?
10:50.
All right. So example 3A, find the value of each variable. So look at this first example. Do I have a triangle or do I have a quadrilateral inside of a circle? I have a triangle. So where would my right angle be? A, B, or C? C. Do we all understand and do we all agree that that is my right angle? Michael, put that away, please. Okay, so because they told me to find x, 2x is going to equal what? What's that degree of that right angle? 90. Do we all understand where that 90 came from? All right, that's what they labeled. All right, so what does x equal? What's half of 90?
45.
45. All right, so when looking at letter B, do I have a triangle inside my circle or a quadrilateral? A quadrilateral. So therefore, opposite angles are going to equal what? Huh? 180, good. So, what's opposite of y? 120, right? So I'm going to do y plus 120 is equal to 180. What does y equal? It will equal 60 degrees. So that means that z in 80 will have to add up to equal 180 degrees. What is the measure of angle z? Guys, seriously, come on. 180 minus 80. 100 degrees. All right, letter C. This one's tricky. Let's first look at my triangle, right? Which one is going to be the right angle? A, B, or C? B. All right. Which is 90 degrees, right? Because they told me that this arc AC is 4x. Well, I don't have a number for that right now, but what I do know is that this is an inscribed angle. If we kept extending those sides of the triangle out past the circle, it is still an inscribed angle. So, if my angle is 90, how do I find the intercepted arc? Let's refer back here. How do I go from angle to arc? I'm going to multiply by 2. So therefore, this purple intercepted arc is going to equal what? 180. Good. So I needed to know that before I could even solve. Because now I can set up my equation to be 4x, which will equal 180. That's what that arc is going to be. You guys tell me what you get for x. All right, someone confirm. You guys get 45? Good. All right, letter D. For letter D, I have a quadrilateral, so I know I'm looking at my opposite angles, because opposite angles are congruent. Sorry, opposite angles are supplementary. So that means that to find the measure of y, I'm going to do y plus 80 is going to equal 180 degrees. What do we get for the measure of y? 100. We get 100 degrees. And to find x, I'm going to add what?
Oh, okay. 85.
I'm going to make that equal 180. So x is going to equal 95 degrees. So we mentioned that a quadrilateral means any shape, any polygon with 4 sides. So this is a kite. Is it still a quadrilateral? Does it have 4 sides?
Yes.
Yeah. Are those still opposite angles? Yeah. They're opposite each other. They're right across from each other. So I'm going to add both of these angles, and it's going to equal what? No. What do we do here? Opposite angles equal 180. Even though it's a kite and not like a typical rectangle or square, the same rules apply. Opposite angles will equal 180. So I'm going to combine like terms and then solve. So I have 8x minus 6 is equal to 180. I'm going to add 6 I have 8x is equal to 186. Lulu, what do you get for an answer?
For the final.
Yeah.
We get
23.25.
which we rounded.
You can just leave it like that. It's not often that we'll get decimals, but sometimes you do. All right, number F. I have a triangle, so I'm looking for that right angle. Which one will be my right angle, A, B, or C? C. So, to solve this, I'm going to have 3x, which will equal 90, because that is my right angle. When I divide by 3, I am left with 30. I know that is overload. I know that this is probably the hardest lesson within circles, but it's also one of the most important ones. Inscribed angles are very, very important. So I want you guys to work on page 13, just 1 through 9, and then we'll go over them. Don't just stare at it and say, I don't know how to do this. Look back at your examples that we just did. There are examples that match all these problems, but the easiest ones are 1, 2, and 3. We should be able to go from arc to angle and angle to arc. Okay? The other ones get a little bit more tricky and have a higher level of thinking, but you guys are capable of doing it. So, take about 8 minutes, 8 to 10 minutes, and then we'll go over it. You do not have to do the bottom part, just 1 through 9. Alright, so number 1, what do you guys get for x? It's 100 degrees. For number 2, what did you get? It's like we're getting the angle to arc to angle thing. For number 3? Alright, so for number 4, they told us that my central angle was 120, which meant my arc here was what? So y was 120. And now I can find what the intercepted or my inscribed angle is going to be. What's half of 120? That's 60. All right, for number 5, you had to think about the full circle is equal to how many degrees? 360. So the full circle is 360. They already told me this part is 170. This part is 150. How do I find this part? Yep, and what do you get? All right, so this is 40. Now that that's 40, I can look at my inscribed angle here, and there's my arc. The blue part is the arc. So x is going to be half of that, which is 20 degrees. Same thing with number 6. The full circle is 360. I know that arc FG is 70, arc DG is 120. What is the measure of arc Y?
170.
Good. So this is 170. I had to find that. And then if I look here, I see that that's my inscribed angle. So what is half of 170? So my angle here is 85 degrees. Even if you didn't get these answers, please write them down. They'll be helpful for your homework. All right, for number 7, I have 2 inscribed angles here. The first one is here. The second one is this guy. They both have the same arc. So that means those inscribed angles are all the same. If my arc is 100, how can I find my angle? Divided by 2. So what is x and y? You should get 50 degrees for both. Huh? Yes. Oh yeah. Got that. Z would be 100. Thank you. Alright, so number 8, it told me that my inscribed angle was 75 degrees. So it's times 2 to get my arc. What's this arc going to be? So B is equal to 150 degrees. So A, I can do 360 minus 150 minus 110. So we're looking at the whole circle now. What is A going to equal? Yes. A is 100 degrees. For number 9, I would start with figuring out what x is. What is x? It's 90, right? Because that's your right angle. So x is 90 degrees. Alright, if we do our principles of a triangle, I know a triangle has 180 degrees. So 180 minus 90 minus 45 means that z is going to also be 45 degrees. And to find y, look at your inscribed angle. Here it is. And so this arc is going to be what? Not 90. From angle to arc, we times 2. So your arc here for this inscribed angle will be 180 degrees. All right, on your homework, you guys have homework number 3. So we do on Monday, but you guys won't be here on Monday, so I'll check it the next time we're here. If we're out next week, just like I told you guys earlier, listen to these lessons and stay caught up. I'll post on Blackboard and remind, just to give you reminders. It's not like you're going to be out and then you'll come back and take the test. Hold on. Skip numbers 17 and 18. Can't do it because it doesn't make any sense. Any questions on what you're doing for homework? All right. Have a good weekend.